Hi guys. So today we are going to do some water quality testing. So first of all, you need to go to a stream. So for this, I went to a little tiny creek that's just right down the street from my house. It does run right between two of my neighbors' houses, so I made sure to ask them first if I could go on their property to go collect my water quality samples, and they didn't have a problem with it. When you get down there, the first thing you need to do is kind of survey the area, take a picture, and establish what is upstream and what is downstream. So the water flows from uphill to downhill, right? So upstream is up the hill. If you're looking upstream, the water should be coming at you. If you're looking downstream, you should be watching the water kind of flow right past you, and it should be going that way. All right, so the first thing that we're gonna do for either if you're collecting water samples with me or if you are doing this at a stream near your house, you're gonna go out and kind of like just do a visual survey of the area and estimate the density of trash that you see. So you're going to determine if the area has like heavy trash, moderate trash, light trash, sparse trash, or it's clean. So I would say that clean is like you can't find any trash at all. Sparse is that you find one or two pieces here and there. Light is, like maybe if you're standing in one place, maybe you can pick up like 5 pieces of trash. And then heavy would be like there's a ton of trash. So maybe like you can pick up maybe 10 or 20 pieces of trash in one place. So after you estimate the density of the trash, make sure you take a picture of it so that we can kind of assess together if you need help figuring out what that density of trash is. And then while you are there, please pick up some trash. So make sure you take a trash bag with you and try and find at least 5 pieces of trash to pick up. If you can find more, great. And then from that, if you're doing this on your own, you probably need to do like 10 to 20 pieces of trash if you can find them. So then you're going to determine the percentage of recyclables that you picked up. So pull out things that are like plastic bottles, aluminum cans, glass bottles. Yeah, that's probably all the recyclables you're going to find. And then other things that are trash are definitely like chip bags, other sorts of things. If you find any hazardous items, so these are considered as tires, large pieces of metal that could be sharp, needles, other sharp objects, do not pick them up. Let somebody know if it's a park that you're going to. Contact the manager of the park and let them know. If you're with me, please let me know immediately so that we can flag that so that people don't get hurt. If you find disposable masks on the ground, only pick those up if you are wearing gloves. Put them directly in a trash bag and make sure that you're washing your hands after you do this really well. So take hand sanitizer with you out in the field to use that immediately then after you pick up any trash. And then especially if you pick up things like disposable masks, make sure you're wearing gloves and make sure you're washing your hands carefully after that. The first test that you're going to do once you collect your water, when you do your water chemistry survey, is the the temperature test. So first you want to set this up. So I just took a thermometer that I have in my kitchen, and I set it in the probe part in the stream, and I let it sit while I collect my water sample so that can kind of take a minute and like equalize to the temperature of the water. All right, I've let this sit here while I collected all my water samples. So now I'm gonna collect this and bring it back in. It looks like my temperature is 42 degrees Fahrenheit. My kitchen thermometer has a mode switch button, so I can even switch it to Celsius maybe. 6 degrees Celsius, there we go. So do not use a thermometer if you're at home that's meant to measure body temperature, because that's probably not going to have a low enough range to get the appropriate water temperature at this point in the year. When I measured the water, it was 6 degrees Celsius or 42 degrees Fahrenheit, and that should be well below any normal body temperature. So make sure you're using either a kitchen thermometer or like a hardware thermometer kind of thing. So, and if you are using a kitchen thermometer, make sure that you are cleaning it thoroughly after you use it. So wash it with soap and water. If it's dishwasher safe, put it through the dishwasher. The same goes for any other kitchen equipment that you might use. So if you use a measuring cup from the kitchen, or if you use like jars or glasses from the kitchen to put stream water in them, please make sure that you clean those very carefully after you use them. Lots of soap and water, or put them through the dishwasher if that's an option. All right. Also, while you're out in the field, you're going to measure turbidity. So you're going to want to find this little Secchi disc in your kit, and you're going to drop that down in your graduated cylinder. You can do this before or after you add the water. It doesn't really matter. So I dropped mine in after I added water, and so I had to use a stick to kind of get it to land on the bottom so that the black and white part was facing up, and it was actually sitting on the bottom. So when you collect your water, make sure that the mouth of the graduated cylinder is facing upstream so that water is flowing into the graduated cylinder. Also, make sure that you're in a deep enough part of the stream or the lake where you are not touching the bottom. Make sure you're not stirring up the bottom, because that will give you a falsely high reading of turbidity. And so after you do that, you're going to, so when you have the Secchi disc in the bottom of the graduated cylinder, and then it's filled up with water, make sure you're in a very bright area, so full sunlight is ideal. And then you're going to take your ruler and you're going to line it up so that the 0 centimeter line is down at the very bottom of the test tube. And you're going to take it, and then you're just going to look straight down into the test tube, and you're going to judge and see how clearly you can see this Secchi disc. So we're going to do 2 different measurements. So you have on the chart that was provided with all of the test results, you have a estimate for 0 JTU, 40 JTU, and 100 JTU. And if you think it's maybe like between 0 and 40, then you could safely probably say that it's about 20 JTU there. So this water level goes all the way up to the 20 centimeter mark. And if we look straight down there, that is very clear. I can definitely see that Secchi disc clearly. So for my turbidity out in the stream, it was completely clear all the way up to that 20 centimeter mark. And so I really don't think that in this case I have a really good way to assess the clarity of the water by depth. So I think my best bet for this is going to be using that JTU measurement unit that's on the chart, and not any of these measurements that are in this reference table. I submerged the small glass tube into the stream with the mouth of it facing upstream so that the water flows into the tube. Okay guys, so I have my little teeny tiny tube full of water for my dissolved oxygen test. So I'm gonna find my dissolved oxygen tablets. They should be in this lovely bag, and it should be either in a separate baggie labeled dissolved oxygen tablets or DO tablets, or I stuck a little sticker on the back of the tablets that says DO, not that you can see that. Oh, maybe there we go. Okay, so the directions say then I need to drop 2 of those tablets directly into here, and I want to leave the lid off for as little as possible because we don't want the oxygen in the air to dissolve into our water in the vial. So I'm going to take these tablets out and then drop those tablets in here one at a time. So there goes one, and there is the other one. Okay. And then I'm going to put the cap back on very tightly. And so the water level is like all the way up here at the top. So there is going to be a little bit of spilling that happens maybe as I put the tap back on. And then it says to mix. So I made sure that there's no air bubbles in there. My cap is on very securely. Then it says to mix by inverting the tube over and over about 1 inversion per second until the tablets have disintegrated. This will take about 4 minutes. So for 4 minutes, you're going to tip it over. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi. All right, you're going to keep doing this for 4 whole minutes. All right, if you have been inverting for 4 minutes or more, and your tablets still have not dissolved all the way, but they're wee little bitty tiny flakes, that's probably okay, and you can just leave them like that. And then you're going to let this sit for 5 minutes. So make sure you set a timer. And then after 5 minutes, we will use the color chart that I'm going to provide to you to look and see what the dissolved oxygen level is. Okay, so I'm going to take all of my water samples that I collected out at the stream, and I'm going to pour them in just another jar so that I can use my test tube and graduated cylinder for measuring things. All right. So for the pH test, I need 10 milliliters of water. So I'm going to use my handy dandy graduated cylinder. I'm going to fill it up to the 10 milliliter mark and then put that into my test tube. Okay. All right. I think I got 10 milliliters of water there. So I'm going to pour 10 milliliters of water into my test tube. And of course now the Secchi disc wants to come out. All right, so once we have 10 milliliters of water in there, we're doing the pH test. So we're gonna find our tablet in our baggie that says pH on it. So again, you might have just a foil tablet that has a sticker on it that says pH, or you might have a plastic baggie that says pH on it, whatever. Doesn't really matter. So open the foil, dump the tablet in the tube, dunk. Cap the tube, and you're going to mix by inverting again. So inverting is just flipping it up and down. This one tends to dissolve a little bit faster than the other one. All right, so now we have our dissolved pH tablet in here, and so you can now take it and compare it to the color chart that is provided in the assignment. So it works really well if you take the tube and you lay it right in the middle of where you are going to, like the numbers on the chart kind of like go from 4 and then up to 7 and then up to 10, like that in a U shape. And there's an empty space in the middle that's perfectly test tube sized. So that's where you're going to put this to read it and to determine what the pH is. Okay, so after you're done testing your pH, so my pH lined up pretty evenly with the 7 color. So keep in mind this is a fairly coarse measurement of pH. It's not super accurate, but it works. It's good, close enough. So I have a second jar, and I'm just gonna put my waste in here. Eventually the waste can just go down the sink with lots of water, and I'm gonna rinse with a little bit of stream water, because that's what I have sitting here. You can rinse with tap water as well. All right. So our next test is going to be our phosphate test. So you're going to need the little tablet that says P on it. So again, this could be in a little baggie that says P tablet. It could be just a little foil packet that has a P on it. So what you're going to do is you are going to, again, fill up your test tube with 10 milliliters of water. All right. And then we're going to add one phosphorus tab, so the one with the P on it. And then we are going to, again, cap the tube and mix by inverting it until it is dissolved. All right. So I'll let you guys do that. Okay, so my phosphate tablet dissolved, and there's still some solids in there, and that's okay. So I set a timer, and I'm gonna wait 5 minutes and let that color develop like the directions said, and then we're gonna use the color chart to read our results. And so keep in mind with all of these results that they are giving you a very wide range and a very coarse measurement of these concentrations or the pH or whatever we're looking at here. And so that's a good idea to give us like a good ballpark of what the water quality is, but it's not very specific. So just keep that in mind when you're interpreting your results. So I just read the results of my phosphate test. So I'm gonna rinse this tube out again with just a smidge of water. So this next test, the nitrogen test, it does require, it's light sensitive. So you do need to make sure that you have something nearby that you can cover up the tube with. If we're in school, we use these like silver foil sleeves. I'm just gonna use a headband that I had lying around. You can use a piece of aluminum foil, you can use a sock, a sleeve of your shirt, whatever. Okay, so again, with this one, we need to add 5 milliliters of water. So very carefully measure out your 5 milliliters of water. Now we are going to take our last tablet, our tablet that is labeled in. We'll pop this out. And then the directions say add it and then immediately add it into the protective sleeve. And we are going to, again, invert it while it dissolves. We're going to invert this for 2 minutes and then wait for 5 minutes while the color develops and the test completes. All right, so I'm going to set myself a timer for 2 minutes and I'm going to keep inverting it and keeping it covered while that tablet dissolves, and then I will set it for 5 minutes and just let it sit covered up. Okay, so we've done all of our tests, so now we need to record our data. So we're going to use this class spreadsheet that is linked in all of the procedure descriptions. So the first one is going to be your trash description. So if you did this with other folks, then you can put their names. Otherwise, you can just put your name. So we're going to call it Valley Run. That's the name of my neighborhood, Third Fork Creek Tributary. And I did it today, which is 3/8/2021. And I say there was no trash there at all. Yeah. So I didn't pick up any trash or find any recyclables, so there's that. All right, so for our chemistry results, I collected my water sample this morning around 9 a.m. So 9 o'clock. And this was a creek or a stream. All right, so my dissolved oxygen was, I called it 6 parts per million because it looked like it was right between the 4 and the 8. The temperature in Celsius, we said, was 6. I didn't measure it in digit or in analog. My turbidity in centimeters was 20 plus. So we said that was not applicable. And this was 0. Said my pH was 7. I didn't use the pH meter, so we're not going to put that there. The nitrate results looked like looked like they matched up with the 5 parts per million spot on the chart. And the phosphate looked like it matched up with about the 2 parts per million on the chart. All right. So after I have put in my results here, I can go and transfer them to those on the worksheet as well. All right, so my dissolved oxygen was somewhere between 4 and 8 parts per million. It was about 6 degrees Celsius out. So that's somewhere between, we called it right in between 32 and 64% saturation. So we'll just take an average of those two numbers to get our oxygen percent saturation. All right, and then down here in our results, all right, so down here in our results, we're gonna take a look at this table here, and we're gonna rank all of our results. So our trash was clean. So what that means, there was no trash. So this is also a very teeny tiny stream, so there's probably not anything upstream that washes downstream either. If you measured from a bigger stream, then there might be some trash that washes downstream. If it's next to a heavily trafficked road, there might be things that like happen to get on the road and wash down into there. So our dissolved oxygen percent saturation, we said, was right between 32 and 64, which will be about 48% saturation. And that falls into our not so great category. So less than 50% is poor. But you're taking the average result from the class spreadsheet, so you're going to interpret that. So this means that maybe there's not a lot of oxygen available in the water for organisms to use. And in a slow moving stream like that with lots of algal growth, that's kind of what I would expect there. Our pH was around 7 for this stream, and that means that it is excellent in terms of pH. Our turbidity was like not really any turbidity, so we're going to call that excellent for this tiny stream that I did. But if you're taking the class average for Burdens Creek, then make sure that you are using that, not this. So 0. And then we didn't do the NTU. Okay. And our nitrate values were 5, so that's fair. And our phosphate values were 2, so that comes out to be good. 5 ppm, 2 ppm. All right, and so now you guys can use this information. If you're with me, then we're going to also take a look at the stream habitat and the and see if we have time to collect some macroinvertebrates and look at those guys as well. So you guys can use these, your values, your average values from Burdens Creek, or you can use just your values if you collected from a stream or a lake that nobody else collected from, and answer the rest of these results questions and the conclusion questions. All right.